This is a video that's going to go over the guided practice 10.9. We're going to start with on the second side. We're not going to be going over the reviews from other sections, but we're going to start with the review with the guided practice specifically about the theorems we discussed for circles. Number one, I'm going to draw this here, shows that two chords are intersecting in a circle, and shows that one chord intersects in such a way so that this segment is 6 length, this segment is 8 in length, and then this other chord intersects in such a way so that this segment is 4 and this segment is x. What we have to remember is we have to remember the formula for calculating the lengths of the segments, which is that we multiply the two pieces for each segment and we set them equal to each other for each chord. So that's 6 times 8, these two segments from this chord, equals 4 times x, these two segments from this other chord. 6 times 8 is 48, equals 4 times x, and therefore we have x equals 12. Okay, that was a very easy one. Let's move on to number 2. This is a different theorem. This theorem has to do with two secants that intersect in a circle. And in this case, we have the formula, the outside of one secant times the whole length of that secant equals the outside of the other secant times the whole length of that secant. So if we look at the first secant, the outside is 2, the whole length is 2 plus x. We look at the other secant, the outside is 3, and the whole length is 5 plus 3, or 8. So that gives us 24 on the right, and we need to distribute out what we've got on the left here, 4 plus 2x. And then we only need to solve for x because we're being asked to find the value of x in each of these cases. So let's go ahead and solve. Subtract 4. 2x is equal to 20, x equals 10. So that is the answer for number 2, x is equal to 10. Let's move on to number 3. And number 3, this time we don't have two secants, we have one secant and we have one tangent. And the length of the tangent is x, and that's what we're trying to solve for. Let's go ahead and do it. Remember what the formula is. For the secant, we've got the outside times the whole, but for the tangent, we've got the tangent squared, or the length of the tangent squared. So let's write that down first. Since the tangent is x, this would be x squared. And then going back to the secant, the outside is 2, the whole secant is 5 in length, 2 plus 3. So we have 10 equals x squared, or x is equal to the square root of 10. So that would be the answer for this problem. Now, you know that when you take a square root, normally we look at the positive and the negative. It's really plus or minus square root of 10. I haven't written in the minus one because you cannot have a minus length. You cannot have a negative length. So we know this has to be, the answer has to be the square root of 10, the positive square root of 10. Moving on to number 4. We now have another secant and tangent problem. We've got the x now is not the length of the tangent, but rather the length of the inside of the secant. So let's remember our formula is that the outside of the secant times the whole length of the secant is equal to the tangent length squared. So now the tangent length is 8. This is 8 squared. The outside part of the secant is 6. The whole part is x plus 6, or I could write 6 plus x. It really doesn't matter. 8 squared is 64. If I distribute 6 over the parenthesis, I get 6x plus 36. I want to subtract 36 from both sides and then solve. I get 28 equals 6x. I divide both sides by 6. I get, let me slide that up a bit. I divide both sides by 6. I get x equals 28 sixths, which I can reduce a little bit.
I'll just go by halves. 14 over 3. I think that's about the most I can do. Or I could also call that 4 2/3. Okay, so the answer is x is equal to 14/3, which is the same as 4 2/3. You do need to be comfortable with fractions. You do need to be comfortable with all of this kind of non-integer arithmetic because it could pop up at any time. I'll be continuing on in the next video.